Hello, algebra friends. It's a Sunday afternoon, and I'm sitting outside on my patio doing the best thing in the world. Going to do some algebra. Hopefully, you'll have as much fun as me. So today we're talking about quadratic equations and special aspects of their graphs and pictures of a quadratic. Now remember, a quadratic equation is an equation who has a highest exponent of 2. The standard form for a quadratic equation is y equals ax squared plus bx plus c. Ax squared plus bx plus. So when you see an exponent of 2 in your equation, you're going to have a graph that is called a parabola. It looks like parabola, but it's pronounced parabola. And parabolas are graphs that come from a quadratic equation or an equation with an exponent of 2. The two main parts of the graph that we are going to focus on today, besides the roots, is the vertex and the axis of symmetry. So as you can see, the vertex is the turning point of a quadratic graph, or the turning point of a parabola, which is either the highest point on the graph, which it would be called the maximum, or the lowest point on the graph, in which case it would be called the minimum. So the vertex is the turning point of a graph that is either a maximum or a minimum. The axis of symmetry is a vertical line that passes through the vertex and passes through the middle of a parabola, splitting in the graph into two identical parts. That's why it's called symmetry, axis of symmetry, or line of symmetry. Symmetric means it's the same on both sides of that line. Like you can fold it in half, where one half falls on top of the other half. It's a mirror image. So we're going to start by looking at those two things, vertex and the axis of symmetry. So what you see, example 1 and example 2, are pictures of a parabola. Okay? Sometimes the parabolas are a U-shape facing up, sometimes they are an N shape facing upside down. And we'll talk about the difference between those two in a few minutes. But the axis of symmetry is the line that goes right down the middle that splits the graph into two equal sides so that the graph could be folded in half. This axis of symmetry is always an x equals equation because it is a vertical line that uses the same x value every point on the line. So the x value for this one is always 1. For all the different points that are on this line, the x value is always 1. So that's your axis of symmetry. The roots, we solve the roots by putting the equation equal to 0 and then solving for x. That means our roots are where y is equal to 0. The roots is when y equals 0. So on a graph, the roots are the x-intercepts. Right there. Right there. So for this question, the roots are at -1 and +3. It's just the x values. When you're asked to find the root, you're looking for the x value. Okay? If they ask for the coordinates of the x-intercepts, then you write it as a point, -1, 0, 3, 0. But if it just asks for the roots, or sometimes they are called the zeros, if you remember from one of the other lessons, it's called a 0 because it's the value of x that makes y 0. All right, the last piece is the vertex. The vertex is the turning point of the graph. It's the point where the graph changes direction from going down to going up. So our vertex is that turning point. The vertex is always on the line of symmetry. They always have the same x value. So if our axis of symmetry or line of symmetry has the equation x equals 1, that x value of 1 is the x-coordinate of the vertex. To find the y-coordinate, we can look at the graph here and see that the y value is at -4, giving us the vertex point. Later, we'll use the equation to find the vertex point. All of these things hold true whether your parabola faces upwards or downwards. So our axis of symmetry is the line that could be used to fold the parabola in half. The equation of the axis of symmetry is always an x equals equation, and in this example, the x value is always -2. Our roots are always where the graph crosses the x-intercept, so our x-intercepts are at -4 and at 0. So that's our root there at -4, and again at 0. The vertex is the turning point of our parabola. It's where the axis of symmetry and the parabola curve meet. That is the point that makes our vertex. So in this case, it's at -2, 4. Now, since the axis of symmetry or line of symmetry splits the graph into two equivalent sides where they could be folded on top of each other, we could use that to help us graph or finish a diagram or picture of a parabola. So the symmetry of parabolas is very important. So symmetry means it's the same on both sides. The axis of symmetry of a parabola splits the graph into two halves that are mirror images of each other, with points that use the same y value for two different x values. And we're going to use this idea and concept of symmetry to answer some questions, and then eventually to help us graph a quadratic equation or a parabola. So here's another example. This example is facing upside down. Just so you know, when a parabola is facing upside down like this, that means the a value, when put in standard form, has to be negative. The a value is going to be negative, and that's what turns our parabola upside down. The a is negative, this a value here. When that is a negative number, our parabola is upside down. So, where is our vertex? The vertex is the turning point of our parabola, so that'll be at 2, 1. Where is the axis of symmetry? Remember, the axis of symmetry is always an x equals equation, and we just use the number to explain where it's located. The x value for the axis of symmetry equation will be the same x value as the vertex. Our axis of symmetry here goes right through the value where x is equal to 2. Every point on that line has an x value of 2. That's the point 2, 3, 2, 2, 2, 1, 2, 0, 2, -1, 2, -2, 2, -3. X is always 2. That's the equation of a vertical line. So we have our vertex found, and then we have our axis of symmetry found. Then it says name a pair of symmetric points on the parabola. So if we are going to have a pair of symmetric points, that means it will be the same y value left and right, but different x values. So we want to find some points that are nice and neat and accurate and easy to read. Let's start with our roots. Our roots are at 1 and 3. Notice they are each 1 square to the left, 1 square to the right, same distance away from the axis of symmetry. That's what we mean by a pair of symmetric points. But since we identified the roots already, we can answer part D. The roots are at the x value of 1 and the x value of 3, and those are also a pair of symmetric points. They are both the same distance from the axis of symmetry, one on the left, one on the right. Another pair of symmetric points, 0, -3, and 4, -3. They use the same y value, but different x values. And that's totally okay. It is still a function, because the function was the other way around. A function uses each x, 1x, for every y. So this does still pass the vertical line test. So a pair of symmetric points about the parabola, we can use the roots, but I'm going to use the other points we discovered, 0, -3, and 4, -3. So if every parabola has symmetric points, we can use that idea to help us finish the picture or complete the graph. So what you have here for number 4 is half of a parabola graphed. I would like you to pause the video and graph the other half. You're going to graph the other half by first recognizing the axis of symmetry. So our parabola is going to come down and be a U shape. This point, 3, -1, is going to be our turning point, or the vertex. So our axis of symmetry is going to be the vertical line that goes right through that point. It's going to have the equation of x equals the number 3. So our axis of symmetry is x equals 3. Our vertex is where the axis of symmetry and the parabola graph meet. So that is our point 3, -1. So now pause it and you can graph the rest of the parabola. So to graph the other half, what we're going to do is identify our point on the right-hand side, count horizontally to the axis of symmetry, and then count the same number of boxes in the opposite direction. So for my root at 4, it is 1 box away from the axis of symmetry, so go 1 box to the other side to make its matching point. Next point that I identify up here at 5, 3, I'm going to count 2 boxes to the axis of symmetry, 2 boxes continuing on to the other side. Then another point up here at 6, 8, 1, 2, 3 boxes to get me to the axis of symmetry, 1, 2, 3 boxes to the other side. And that would be the other half of my parabola. Connect the dots to make it curved, and there we go. So, what are the x-intercepts? Well, our x-intercepts are the same thing as the roots, sometimes also called the zeros. But when it asks for the x-intercept, we want to write it as a coordinate point. So one of the x-intercepts is over here at 2, 0. And the other x-intercept is over here at 4, 0. Now the reason why that these are sometimes called zeros is because it's the value of x where y is 0, as you can see from the coordinate points. This is the x value of 2 when y is 0, x value of 4 where y is 0. The y-intercept is the point where the graph intersects the y-axis, and that's up here at 0, 8. Just like when we did y-intercepts for the equation of a line, it's where the line crosses the y-axis. The y-intercept is where the graph crosses the y-axis. Okay, below we see 1/2 of a parabola. Remember, if it's facing upside down, that means the a value from our standard form equation would be negative. We see the quadratic function, we see the turning point, and we see a table of values that is not quite filled in. Some of it is. We're going to finish it. Find 3 additional points of the quadratic function. What's the turning point? What's the axis of symmetry? Well, let's start with our turning point. Our turning point is the same thing as the vertex. So that's going to be the highest point on the graph because our graph faces upside down. So our turning point is 0, 3, which is also our vertex. If we were to draw the other half of this graph, we know that it would kind of be symmetric, kind of look like that. But we don't have enough graph paper to accurately read those points, so we're just going to have to figure it out by using the table this time. So using our table of values, we're going to figure out the missing y's. As far as the x values are concerned, we can just continue the pattern, -3, -2, -1, 0, 1, 2, 3. For the y values, once we know where the vertex is located, the coordinate points will be symmetric. So we would have a point on the graph somewhere over here, and another one over here, but the y values would be the same. So when I know that the vertex is where the vertex is located, I know that is the middle point on my graph, which means the y values will be a mirror image, not only in the picture, but also on the table. So if the vertex is the point in the middle, then from that vertex point, the y values will match as you move away from that point on the table. That means the next point that's not seen on the graph or the table can be predicted to be the point 1, 2, because it would have the same y value so that the table is symmetric. The next coordinate point would then be -1. Again, so the table is symmetric. And then the next y value after that would be -6. So what we're seeing here is that the points around the vertex would have the same y values. They would be symmetric in the table just like they would be in the graph. And that's going to happen up and down the table for as much as we need. -6 there, -6 there, because the vertex is in the middle. The axis of symmetry, remember, has the same x value as our vertex. The axis of symmetry equation is always x equals, and it's the same number x as our turning point. So in this case, it's x equals 0. So let's do this again. Here we have some random scattering of points, but we're going to complete the graph. And how are we going to determine what additional points we need to graph? Well, let's read the question first. The point 4, -2 is the vertex. So that means this is our vertex. That's the middle of our graph. And I can tell from the picture that it's going to be a U shape, because our vertex either has to be the very highest point or it has to be the very lowest point. If there are other dots above it, that means it's going to be the lowest or a minimum. The points 8, 6, and 2, 0 also fall on the graph of this function. Complete the graph of this quadratic function by first finding 2 additional points on the graph. How will you determine what additional points you need to graph? We're going to use the concept of symmetry. If 4, -2 is our vertex, that means our axis of symmetry is the vertical line that passes through that point. So our axis of symmetry is going to be a line right down the middle of our graph where x is equal to 4. That means all of the points that I know of will be mirror images of each other on both sides of that line. So that's how I can get some additional points. The point 2, 0 is 2 boxes over to get to the axis of symmetry. So go 2 more boxes over and plot a second point or another point. We can do that same thing, same process with the point 8, 6. Go to the point 8, 6, count sideways to our axis of symmetry, 1, 2, 3, 4 boxes, and keep going the same number of boxes on the opposite side, 1, 2, 3, 4. Now we have a bunch more points that we can connect and get a general idea of what this graph should look like. So I know it's supposed to be a U shape. I'll start from my vertex and kind of curve it up to the side this way for 1/2. Same thing over here, curve it up to the side over there, and there's our parabola. Our axis of symmetry, again, uses an x equals, and it's the same number as the vertex. So it's the same x value as the vertex, so our equation is x equals 4. Now, we can find some of these things algebraically as well. We talked before about the standard form of a quadratic when we were doing the quadratic formula. For our graph to be a U shape, A is positive. And for our graph to be an N shape, A is negative. Just like it says for our maximum and minimum descriptions. The equation for our axis of symmetry, we're going to use this equation when we don't have a graph. When we have an equation and nothing else, and we're asked to find the axis of symmetry, this is the equation we use. Taking this, remembering that x value from the axis of symmetry is always the same x value as the vertex, then if x is equal -b over 2a, then for our vertex point, the x value is equal to -b over 2a. If we want to find the actual coordinate of the vertex, I would take whatever x value I found by using negative b over 2a, plug it into the function, and then the y value, or the number that I get, is the y coordinate. And I'm going to do some examples to help you sort out what I was just describing. So let's just get into it. The more we practice, the easier it is to remember and learn. Doing it helps. So let's do it. The equation f of x equals x squared minus 4x plus 2 represents a parabola. Use the equation to determine each of the following. The axis of symmetry. So we have an equation for the axis of symmetry that you just supposedly wrote down on your paper, or at least listened to me talk about briefly. The axis of symmetry equation is x equals negative b over 2a. So remember that the a value is the number in front of the squared term. So in this case, a is equal to 1. The b value is the number in front of the x term. So in this case, b is negative 4. And the c value is the number that has no x to it at all. In this case, a positive 2. According to the formula for the axis of symmetry, we need to negate the b value of negative 4 and divide it by 2 times the a value of 1. So negating negative 4 turns it into positive 4. 2 times 1 is 2. And then 4 divided by 2 is 2. So our axis of symmetry is at the vertical line where x is equal to 2. Now that we know the x value, the coordinate for the vertex needs a y value to go with it. So we are going to plug in that x value into the equation, and we are going to do a little calculation to help us find the y value. So we're going to take our function and plug in 2 everywhere that there used to be an x. So it becomes 2 squared instead of x squared, minus 4 times 2 instead of 4x, and then plus 2. So now we can either go to the calculator or just do this out by hand. Numbers aren't too huge. You can just go type this all into your calculator at once and hit enter and get to your answer. But either way, we end up with negative 2 as the y value. Remember that the f of 2 is the same thing as saying it's the y value. So that means our vertex is at the point where x is 2, y is negative 2. So is this vertex point, 2, negative 2, a maximum or a minimum? And the answer is going to be a minimum, because the a value in the equation equals 1. It's positive. So that means our parabola is a U-shape. So the vertex is a minimum. So if the a value is happy and positive, then it makes a smiley face. All right. So if a is positive, then our parabola is happy and makes a smiley face. For each of the quadratics shown, find the axis of symmetry and the vertex algebraically. State if the parabola has a maximum or a minimum, which means if it opens up or if it opens down, and how we know this. Use the calculator to verify your findings. So to use the calculator to verify your findings, that means you're going to go to the y equals, or to the function location, the graph, and you're just going to type in the equation and look at the picture. All right, so we're going to look at the picture and see which way the parabola opens. That way we know whether our vertex is a max or a min. We are supposed to know from the equation, but it's always good to check with a picture. So we are going to do the algebraic way first. The formula for the axis of symmetry, that's what we find first, is x equals negative b over 2a. Our a value this time is negative 1. Our b value this time happens to be negative 4 again, and c this time is 8. The numbers we need for our formula, negative b over 2a, so that is negating the negative 4 over 2 times negative 1. Negating negative 4 is positive 4. 2 times negative 1 is negative 2. And 4 divided by negative 2 gives us an x value of negative 2. So our axis of symmetry is at the line x equals negative 2. Once we know the axis of symmetry, we're going to plug the number negative 2 in for x back into the function. So we're going to find f of negative 2. So we are negating negative 2 squared minus 4 times negative 2 plus 8. So we can go to the calculator, type this in exactly the way you see it with parentheses and everything, then hit enter. Calculator will take care of the order of operations for us. Or I can do it by hand, where negative 2 squared, negative 2 times negative 2 is positive 4. But this negative sign gets brought down, making it a negative 4. Negative 8, the negative 4 times negative 2 turns into a positive 8, and then we still have the plus 8. So we end up with negative 4 plus 16. 16 minus 4 is 12. That's the y-coordinate of the vertex. So our vertex is the point x, negative 2, y, positive 12. So is this point a maximum or a minimum? So is our parabola happy or is it sad? Well, our parabola has a negative in front of the x squared term. That negative there means our parabola is sad. Frowny face parabola. And the frowny face parabola means the vertex is a maximum. The vertex is a maximum because A is negative. And that's how we know right from the equation before even looking at the picture. But let's take a look at the graph anyways. So I have some stuff already in my graph. What I'm going to do is take some action and delete it. That way my graph is now clear. Now I'm going to menu. I'm going to option 3, graph entry, and option 1, function. I'm going to type in the equation that we just were working with, which is negative x squared minus 4x plus 8. I'm going to hit enter and take a look at the picture. So we can tell just from the picture, even though we don't have the table of values or we don't see the whole thing, I can tell from the picture that the vertex is going to be the highest point on the graph because our graph is facing upside down. So that means our vertex is a maximum just like we described. Okay? If I needed to graph this, I would just hit Control T and plot the points from the table that fit on my paper. And that's how we're going to graph it. But that's not yet. That's in the next page. That's the last 2 questions. Let's do one more practice of finding the axis of symmetry and the vertex. So if you could pause this, please pause it and try it yourself. I'll get you started with this equation. This time a in front of the x squared is the number 2. When you look for the b value, you don't see an x value there. So that means this time b is 0. And then c is the negative 6. So plug those numbers into x equals negative b over 2a. Get the axis of symmetry, then plug that into the function to get your vertex. So pause it, try it, and then come back and we'll see how you did. So when you plug in the b value of 0 into the numerator of the fraction, negating it doesn't do anything because negating 0 doesn't change it. It's still 0. So we end up with 0 over 4, which is just the number 0. So our axis of symmetry is at x equals 0. Plugging that number into your function, finding f of 0 means 2 times 0 squared minus 6, which would be 2 times 0, which is 0 minus 6, so it's just at negative 6. So our vertex if you did it right, is that x value of 0, y value of negative 6. Now, is this a maximum or a minimum? Well, because the a value here, a value is positive, our graph will be a U shape. So the vertex is a minimum. Because a value is positive. All right, we're almost done. We're going to do 2 graphs. I just want to show you how to graph a parabola, and then we're good for the day. So to graph a parabola, we're going to use our calculator. So if you want to practice finding the axis of symmetry, remember that it's the formula x equals negative b over 2a. For this example, the a value is positive 1, the b value is negative 7, and your c value is 6. We can plug the numbers into the formula, and we can get our axis of symmetry. So we would negate negative 7 divided by 2 times 1. And what you'll notice is they're not always going to divide out to be nice, neat numbers. So we get x equals 3.5, 3.5 for our axis of symmetry. And then when we plug in 3.5 back into our equation, we're going to get another decimal. But we can do it. Just take a look, see what would happen. So we'll do 3.5 squared minus 7 times 3.5 plus 6. So if I type that into my calculator, I'm going to do 3.5 squared. I'm going to use parentheses around the 3.5 to make sure that I don't mess up any operation orders. So I'm going to basically type it into my calculator exactly the way I see it. And when I do that, I get negative 6.25 as the y-coordinate. So I know my vertex is at an x value of 3.5 and a y value of negative 6.25. Not the most convenient numbers to work with. So another option when it comes time for graphing that's going to make things work a little easier for us is to make a table of values. And we're just going to copy this table of values right from our calculator. So our equation was x squared minus 7x plus 6. And that's what we're going to type into the calculator. So I'm going to go back over to my calculator, get rid of my table, and I'm going to view my entry line. So I hit menu, number 2 for view, and number 3 for graph entry line. Then I can move my cursor over to this history menu and go back to function 1 and just type in the new function. Delete these things. So I use my delete button to clear out the old function. I'm going to type in the new equation, and that way I only have one equation to worry about. So I'm type again, x squared minus 7x plus 6, and then hit enter, and notice my picture changes. Now, according to the work we did, we saw that our axis of symmetry was at x equals 3.5, which seems to be about right. 1, 2, 3.5. There we go. That's where our axis of symmetry would fall. And then the vertex was at 3.5, negative 6.25, which looks about right. So how do I get the picture? Well, I'm going to go to the table of values by doing Control T, and then I'm going to look at what points from the table would actually fit on my paper. So my graph paper doesn't go past 14, so I'm going to ignore that point, but I have some other whole number values that I can graph. So back over to my picture, and I'm going to write these down for you. One of the points that we found, it was going to be right in the middle, was the x value of 3.5 and the y value of negative 6.25. That's our vertex. That's the middle point. So what I'm going to do is just write the coordinates of the points that would mirror that, be the same, our symmetric points. That's what I'm getting to. We're going to plot our symmetric points. So I have the point 0, 6 from our table, 1, 0 from our table of values, 2, negative 4. I'm going to squeeze another one in here. Of 3, negative 6, because that is on my table. And then mirror image on the other side, 4, negative 6, 5, negative 4, 6, 0, and then 7, 6. Remember that our y values in the table are mirror images of each other from the vertex out to the sides. Okay? That's going to help us get some points. Now, let's plot these points on the graph, and then we'll be done with it. So, 0, 6, 1, 0, 2, negative 4, 3, negative 6, and then 3.5, negative 6.25 would be our vertex. Now, once I have that half graphed, it makes it a lot easier to graph the other side, because I just go sideways one box and match the y value, the height for the dots on the other side. Then I tried nice and carefully to make this a curved parabola, and then we have our graph finished. Boop. I try to make it curved. Sometimes my hand's a little shaky, or sometimes plot a point in the wrong spots. So, okay, now my points are adjusted. Connect them with a curve to make it look like a parabola. Oops, got a little wiggly there. Doesn't have to be perfect, but it should look rounded, curved at the bottom, not a V shape. And that's how we graph. So we're going to do one more graph. If you think you got it, then good. But it's always helpful to practice again. So we'll do one more. Axis of symmetry. Our axis of symmetry equation, x equals negative b over 2a. Our b value is positive 2. The a value is negative 1. So we end up with negative 2 divided by negative 2, which is positive 1. So x equals 1 is our axis of symmetry. So I know that on both sides of this vertical line, I'm going to have mirror image points. All right. The vertex. To find the vertex, I'm going to plug in the positive 1 in for the x into the equation. So I end up with negating 1 squared, which is negative 1. 2 times 1 is 2. And then a minus 1 at the end. This ends up positive 2 minus 2. So it's 0. So our vertex is at the point 1, 0. So our vertex is at the point 1, 0. That's our turning point. So the next thing to consider is, will our graph be a happy face, a U shape, or a frowny face, N shape? And because the N value, the A value, at the very beginning of our equation is a negative, I know our graph's going to be upside down in an N shape. But it doesn't really matter, because what we're going to do is look at the table of values and let the table of values from the calculator give us some nice, neat, accurate points to graph. And I know that the point in the middle is the point 1, 0, which we already have on our graph. And I'm going to go to the calculator. Negative x squared plus 2x minus 1. Control T turns off the table. Menu. View number 2. Show entry line number 3. And history menu. I'm going to go to F1. And we have negative x squared plus 2x minus 1 plus 2x minus 1. And as I suggested or told, it was going to be upside down. Control T to get to our table of values, and we'll plot the points that fit on our graph. I know that the axis of symmetry is at x equals 1, so that means I also know that the point 1, 0 is our vertex, and I should see symmetric y values from that vertex up and down from the table. So I have 0, negative 1, negative 1, negative 4 as a couple pair of points. So I have 0, negative 1, negative 1, negative 4. If I want to get another value, just go to the next spot on the table. And remember that our numbers will be symmetric. So at 2, it'll be negative 1, 3 is negative 4, and 4 is at negative 9. So let's plot these points, get our graph, and be on our way. Negative 2, negative 9, negative 1, negative 4, 0, negative 1. And since our points are symmetric on each side, it makes it a little easier to graph. And then when I connect them, I try to do it nice and curved to show that it's a parabola, not a V shape. It is a parabola. And we are done. Sorry this was so long, but we covered a lot of important information. Hopefully you took good notes to use on your test. And I hope I made your day wonderful by doing so much extra algebra. Take care, guys. Talk to you soon.